In this video, we're going to look at solving an inequality by using a table of signs as an alternative to graphical methods. So let's have a look at this inequality. So we have 3 over x plus 2 less than or equal to x. Now, before I use a table of signs, the first thing we need to do is to basically move everything over to one side. Move the x over to the left-hand side. And then we have a 0 on the right-hand side. So let's do that first. So 3 over x plus 2 minus x less than or equal to 0. The next thing we're going to do is to basically combine the x and the fraction 3 over x plus 2 into a single fraction. Okay, but in order to do that, we need a common denominator. So common denominator is going to be x plus 2. So let's do that. And I'm going to multiply the x by x plus 2 over x plus 2. And of course, that's less than or equal to 0. Now let's combine the numerators together. But in doing that, as well as doing that, I'm going to also multiply through negative x to x plus 2. So I'm going to expand that bracket there. So 3, okay, so that's going to be minus x squared minus 2x over x plus 2 less than or equal to 0. Okay. So we can observe that the numerator there is a quadratic function of sorts, of course, although the x squared there is negative. It'd be nice if it was a positive, just makes it easier to factorise. So what I'm going to do is I'm going to multiply both sides by -1. Yeah. Now recall, if you multiply or divide an inequality by a negative number, we need to flip the inequality sign around, or we'll just switch it around. Okay, so instead of less than or equal to, it's going to be greater than or equal to 0. And it can be written now as x squared plus 2x minus 3 over x plus 2 greater than or equal to 0. In fact, I'll just write that a little bit closer so it just makes it a bit clearer. There we go. Okay, and probably the next logical step would be to factorise the numerator. Okay, now it's nice and simple to factorise. So that'll be x minus 1, okay, x plus 3 over x plus 2 greater than or equal to 0. Okay, so we can see that this inequality, or at least the left-hand side, really it's a kind of a quotient of two functions. We have a quadratic in the numerator, but we have a divided by a linear, so it's kind of like a hyperbola of a sort, or in fact, there will be branches involved, because if you look at the denominator x plus 2, in fact, when x is equal to -2, there'll be a discontinuity. The function's not defined, so there'll definitely be a vertical asymptote there. And the numerator, of course, won't be 0 as well when x is -2. So I think the next step now would be to draw up a table of signs. Now, we could graph the left-hand side and just look at where the function's greater than or equal to 0, and then we can quote our inequality. But a table of signs is just, I guess, another way of solving an inequality where, I guess, graphing can be impractical or might take too long. So it's a nice, elegant method. So let's do a table of signs. So before we do that, though, let's note some critical points. So we have a discontinuity. Okay, so x equals -2. And we also have zeros as well. So okay, and we have -3 and +1. Okay, so they're our three critical values. Now, drawing up a table of signs, and a nice little rule to remember here is the number of critical points that you have. If you double that and add 1, that should be the number of columns in the table of signs. So I've got 1, 2, 3 critical values. Double that, that's 6. Add another one, 7. You'll see why it's adding. You need to add an extra one. So let's see if I can fit that in there. So I might use up the whole sort of right half of the board. Okay. So the first row will be x, the second row is y, and the third row is the sign. Okay, so let me just see if I can squeeze in the 7 columns. 1, 2, 3, 4, 5, 6. Yep, no, I think that's fine. There's our sim. Okay. Now, the critical values, we place them in alternate columns and never from the first column. So starting from the second sort of blank column, okay, let's put in our -3. Okay, I'm going to put this in ascending order, these critical values. Skip a column. The next column is -2. Skip a column, and we'll write in 1 there. So these are our 3 critical values in ascending order. Okay. Now, we know that the function is 0 at -3 and 1. And the sign of 0, well, that's just 0. Okay. And we also know that there's a discontinuity at x equals -2, so that's where there's a vertical, if you were to graph it, that would be where a vertical asymptote would go. So I'm just going to put a star there because the function is in fact not defined. Now in the remaining 4 columns, what we're doing is we're testing values on either side of these critical points. So it's a bit like the method of solving an inequality using the critical values method, and where you identify your critical values and then you sort of test around it to see if the inequality is true or not. So I guess we're kind of doing a similar thing. So let's choose some convenient values that are in between and around these critical values there. So we've got -3, so maybe we can put -4 here. I'll use a different color just to show that you don't have to use a different color, of course, but I'm just showing this for the purpose of the demonstration. Between -2 and 1, maybe a 0, -2.5 here, okay, and maybe 2 there. So what I'm going to do is I'm going to pause the video now. I'm going to work out these values and we're going to unpause the video and continue on with the explanation. Okay, so what I've done is I spent just a little bit of time there just working out these values. So of course, using a calculator, I just work out the values of y for these x values. So you can see that I've already filled out the middle row here, the y values or the function values. So let's fill in the final row, the sign. So that's -0, that's positive. Okay, -1.5, that's a negative, 0, and we've got a positive there. Okay, so at this point now, using the table of signs, we can now quote our solution, or we can read the solution from this table of signs. So remember that we've rearranged the inequality now. So this is what we're looking for. So we're looking for the columns that are 0 or positive. In fact, I'll just tick those. Okay, so basically wherever the function now is either equal to 0 or positive, let's select those columns. So that column there, that column there. We can't select the discontinuity, of course. 0, no, it's negative. 1, yeah, that's 0, and we have as a positive in that column there. Okay, so therefore, okay, x must lie between -3 and 2, but x obviously can equal -3, but can't equal 2. So that would be written like this. So -3, x greater than or equal to -3, but less than -2, or x can be greater than or equal to 1. Since anything, any x values 1 or more, the function is going to be positive. Okay, but sort of forever and ever, because they're the only critical values that we have, and beyond 1 there's no more critical values. Okay, thanks for watching and wishing you all the best for your studies.